I'm on my Mac, I'm using Visual Studio Code, and I've already installed the LiveShare extension. So what I'm going to do is go down to the status bar and click this Share button. What that's going to generate for me is a link that I can give to Amanda to get her help in my context right here. So if we switch back over to Teams, you can see from our thread that Amanda's already pretty used to me bugging her for help, kind of like right now. So let's paste this link in and then see what it looks like from her machine to join my session.
All right, so all I have to do is go ahead and click on this link, and it'll automatically launch the preferred developer environment that I use, which is Visual Studio. Now notice, I'm on Windows, he's on Mac. I'm on Visual Studio, he's in VS Code. He likes techno party theme colors, and I like a little bit more classic themes. Now, as we join in Visual Studio, you'll see that it's populated by the context that's actually on Jonathan's machine. I have none of the dependencies that he has to run this source code. I didn't clone the repo. I don't have Node installed. I basically have nothing installed that he has a dependency on. And yet, I get all of the context and all of the language services here in Visual Studio. Now, as soon as it connects, you can see that I'm automatically brought to the place where his cursor is currently at, and I can see his cursor move around. I can also see him select things so that we can get a shared context really, really quickly and start working together. Even further, I can independently investigate what's going on in the folder so that I can look at other code to get my bearings a little bit. All right, Jonathan, now that I'm in, what's going on?
So the guest book isn't showing photos anymore, and I kind of think it's related to this code right here, but I'm not exactly sure. Any ideas what's going wrong?
Well, I have no idea looking at this, but I really can't think straight with red squiggles, so that's the first thing I have to take care of is this linting error. Now, as you guys can see, as I move around in here, I get the same experience that you would expect from Visual Studio. You can see I get that tooltip. I can go ahead and get completion lists and select const. All right. So, and as I move my cursor off, you can see that background compilation kicks in, and I have the confidence that fix worked. But that still is not enough for me to know what's going on from a debug perspective. So I can go ahead and inspect other things here, look at a peak definition of this value, and yep, this method is definitely, I think, what's going on. So I'm just going to go and promote that to the Dockwell.
Now, as you can see, at this point, Amanda and I are actually in entirely separate files, which is cool and not something you could achieve with screen sharing. But if at any point I want to refocus with what she's doing, I can choose to follow her cursor. What's great about this is it allows us to work independently or together, depending on what the situation demands.
And then Rasputin.
All right, Jonathan, I think I know what's going on, but to be really confident, I'd like to set a breakpoint on this line and debug.
All right, and as soon as Amanda sets that breakpoint, it shows up on my end as well. What's really important about that is that LiveShare is not just an editing platform. It is real-time collaborative development, which we all know development includes debugging. So because we're in the context of a LiveShare session, if I go and press this play button, it's going to launch that app, share it with Amanda, and hit the breakpoint that she just set.
All right. Pretty cool. Now, as soon as Visual Studio detects that he's at a breakpoint, I get moved into a debug session as well. And you can see that I get all of the capabilities that I would expect in a Visual Studio debug session. I can look at the call stack. I can look at locals and expand to understand what this is. I even have a shared debug cursor. I have access to the same execution point that he has. So I can go ahead and even step over and then get hover tips to understand what the values are. And I can see that, yep, Jonathan, I think I figured out your problem. This signature is 44, and it really should be an object. So you're calling unshift on array, but it really should be shift. So I'm just going to save that, and I think that should work.
All right, now I'd really like for Amanda to be able to verify the fix that she just made before I let her off the hook, but the Guestbook app is running local on my machine, and I'm not ready to deploy it yet, and I certainly don't want to expose it over the internet. But because LiveShare provides us with a secure connection between my and Amanda's machine, I can actually share the web app that is running on localhost with her so that she could see it as if it was running on her machine.
All right, so all I have to do is go ahead to our share session up here and look at shared servers, and you can see that I get access to his local host. I can go ahead and launch that in the browser, and I can see the app straight away, even though it's localhost hosted on his machine. Looks like we fixed the issue.
All right, I'm feeling a lot better. Thank you, thank you, thank you. So I'm kind of out of hot water at this point, mostly, but let's make sure that we didn't regress anything else and run our tests. Now, the Guestbook app, like many modern applications today, actually runs its tests from the command line. But Amanda's not standing right next to me to run that or view the results with me. But once again, because LiveShare provides that secure connection between the two of us, I can also share a live terminal instance with her that she will see on her end and can then run our tests and let us both view the results in real time.
So as soon as he starts that terminal, it's shared. And this isn't just a terminal that's specific to this debug session, it's actually a shared terminal access to his machine. So I could use this to inspect, developer configuration, for example, and see what version of Node is running. But in this case, I'm just going to use this to call our tests. And we both see the results at the same time. It looks like it's good.
Yeah, so we fixed the app. I think the test results speak for themselves. LiveShare is awesome. Thank you so much, Amanda.
Awesome.
High five.
Ready to go live.
Yeah.
Great. Thanks.
Thank you.
And I'm excited to share that Visual Studio Live Share is now available for you to start using today. So you can start downloading it. Please wait till the end of the keynote, but you're welcome to start using it. And I'm also really happy to announce that we're making it free for all Visual Studio and Visual Studio Code developers on every platform. So one of the things you probably noticed over the last few years is a change in how Microsoft approaches open source. We not only now support open source projects in a deep way, but we also have open source much of our own product development. VS Code is just one example of the type of open source projects we help lead now. It's developed in the public on GitHub, and it's had over 17,000 developer contributions to it to make it even better. And VS Code is just one example of how we're really trying to change our development approach to be much more open and inclusive at Microsoft. Things like .NET Core, NuGet, PowerShell, and our Azure SDKs. Are other examples of where we're taking Microsoft projects that are now developing in the open and hosting them on GitHub. And what I'd like to do is invite Jason Warner, the Senior Vice President of Technology at GitHub, on stage to talk a little about GitHub and some of the changes they're seeing as part of this engagement, as well as to talk about some exciting work that we're launching together today. So please join me in welcoming Jason.
Hey, Scott.
Well, welcome, Jason. Thanks for being here. Can you tell us a little bit about GitHub and the mission you guys have for developers?
Sure. Thanks, Scott. Yeah, GitHub's core mission is to make developers' lives better. We started this by revolutionizing code collaboration. Today, the majority of the world's code, both public and private, sits on GitHub with 27 million developers collaborating across 80 million repositories. We view ourselves as stewards of developers, and we aim to reduce the friction in the entire software development lifecycle to get developers back to doing what they care about most, which is writing code.
That's awesome. So yeah, we very much obviously share your vision in terms of both how developers and specifically open source can really fuel innovation. And that's really, as I talked about, one of the core reasons why it's become such a critical part of our engineering culture over the last few years.
I think it's amazing to see what Microsoft has done in the past few years. The industry has shifted and realized the power of open source. And in fact, I don't think it's too bold to say that open source now powers modern software development. And Microsoft might be the best example of a corporation embracing open source. We know from statistics that we have in GitHub that Microsoft is the single largest corporate contributor to open source on GitHub, and thereby extension in the history of open source. In fact, Microsoft has the largest open source community in the entire world with Visual Studio Code.
I know in addition to contributing in projects and hosting on GitHub, one of the other things that our two teams have been working on a lot has actually been on several other projects in terms of technology integration that we've done. I was wondering if you could share a little bit about those and from your perspective how it's helping developers.
Absolutely. We've been able to accomplish a lot over the past few years. Last year at Microsoft Connect, we announced our combined work on GVFS, which allowed Git to scale to the world's largest repositories across Windows and Linux. And with our shared developer focus, our areas of interest seem to overlap more and more with each passing year, and I'm excited to see us working this way out in the open.
I know our teams have been working hard on something new that we're launching today, and that GitHub's doing even more broadly across your ecosystem. Can you tell us a little bit more about what you guys are rolling out and how we're integrating?
Absolutely. Today, we're announcing the public beta of the GitHub Checks API, which will allow our partner integrators to do very deep, annotated, and rich data sets across all manners of continuous integration, including linting and code analysis. And we're excited to see what you're all going to do with that today.
Awesome. Well, thanks so much for joining us, Jason.
Thanks, everybody.
Well, as Jason just mentioned, one of the things that we're excited to announce today is some of the deeper integration that we're doing between GitHub and our overall set of Azure and Visual Studio DevOps capability. And the first scenario that we're releasing today is integrating the mobile DevOps tooling support that we provide with Visual Studio App Center directly within the GitHub experience. Now, VS App Center is something we launched late last fall, and it enables mobile developers to build, test, and distribute mobile apps to a wide variety of different devices, including both iOS and Android, to monitor the performance of those apps, as well as to collect analytics and crash dumps from them, so you can quickly improve your app with each release in a nice iterative way. And we made all this easy by integrating all of the different DevOps stages into one smooth workflow. And what's great with our GitHub partnership is we've now taken that and directly integrated it as well within GitHub as part of that experience. What I'd like to do is invite Samina, who leads the PM team for VS App Center, on stage to actually show off VS App Center and the great integration we now have with GitHub. Here's Samina.
Thank you, Scott. I am so excited to show you today how with App Center and GitHub, we take developer productivity to a whole new level. From pushing code to the repository to shipping the app to the App Store in under 3 minutes. Ready? Here in GitHub is the repository for the Smart Hotel demo app. This is an iOS app written in Swift, but the same steps work for apps written in Xamarin, React Native, or Android. The dev team has been working on a new feature, and they opened the pull request. And here in the pull request, GitHub automatically detects that no continuous integration has been set up and takes me to the GitHub Marketplace for available GitHub apps. I am looking for a mobile CI solution, and App Center is right here. To start building my repository in App Center, I need to install the GitHub app. App Center has a really great free tier, so I will go ahead and install it.
Got it.
I am now completing my free purchase. And finally, I am giving App Center access to my repositories. Now I am in App Center. And when I select the Smart Hotel repository, everything gets automatically detected. No need to enter anything manually, so I can simply continue. App Center does the magic and detects all the build settings. So now, we are ready to kick off a build. Behind the scenes, Azure provisions a virtual machine with the latest tools, pulls the repository, starts a build, and when the build is completed, securely deletes the VM. With Azure, you can get from your repository to setting up continuous integration in under 3 minutes. And back to the demo app, the build is already running. Now this build will take 1 or 2 minutes to complete. But once the build is completed, App Center will report the status back to GitHub. And here in the pull request, I can see all the checks have passed and the build is successful. Now before merging the pull request and distributing the app to my users, I want to run a suite of automated UI tests and to make sure that no regressions were introduced. Epicenter offers thousands of devices with different operating systems and languages, all hosted in Azure. And here we can see how the test cases look for the iOS version run on real iPhones. But remember, Epicenter also supports apps written in Xamarin, React Native, and Java. So I ran the test for the Android version of the Smart Hotel app on over 100 Android devices. And all you see here are real physical devices hosted in the Azure cloud. Now, if we look closer, some of the tests are failing. And looks like on this device, the app did not transition to the home screen. So later, the team can trouble through the issues, look at the test logs, and fix the issues. We have now seen how the app is continuously building on every change. UI tests are validating the user flows. So now we are ready to publish the app to the App Store to our end users.
What do they want?
In the past, we might have done this manually over and over again.
They need Rasputin to do it.
But now we can use the same continuous delivery process and do it automatically with Epicenter and GitHub. So I will configure the master branch that for every successful build, it will automatically distribute it to the App Store. All I have to do is enable distribution to production right here. And with this, every new pull request merged to the master branch will trigger a new build in Epicenter. UI tests will be running, and once everything looks green, the new release will be uploaded to the App Store. Continuous delivery for your mobile apps has never been easier. Together, Epicenter and GitHub make app developers more productive. Get started today. We know you are going to love it. Thank you.
So VS App Center is just one of the DevOps tooling components that we provide as part of the Visual Studio family and Azure set of DevOps tooling. With our Visual Studio Team Services family of tools, we're making it easier to adopt a DevOps-based model and set your team up for success, regardless of the application type that you're working on. VSTS is fully integrated into Azure and includes everything that you need and works with every language and runtime environment that you already use. And what I'd like to do now is invite Donovan Brown, who leads our DevOps advocate team on stage, to show off how easy it is to get started using DevOps in Azure using Visual Studio Team Services. Here's Donovan.
Thanks, guys. Good morning, everyone. Let's try that again. Good morning, everyone. Good morning. Perfect. You know what time it is. It's time to rub a little DevOps on it and make it better. When we combine the power of Visual Studio Team Services in Azure, magic happens. We get to witness this magic every day as Visual Studio Team Services deploys itself into Azure. This gives our teams a unique perspective on how to apply DevOps best practices when deploying into the cloud. Let me show you how they do it. This is an actual dashboard of one of the teams that bring you VSTS every single day. It's customized to show how many days are left in the sprint and what work is currently assigned to them. We can also view this work on a Kanban board. This is a real-time status report. To update your status, you simply drag and drop. But this happens to be where our team actually works, so I probably shouldn't be moving any of these files around. Our team uses Git. And when you use Git, sometimes the branches get out of control. You don't even remember why you created some of those branches, but not when you use our Kanban board. Here, you're able to create a branch right from the board, and this branch is now associated to this work. Every single pull request, every single commit, every single build, and every single release is automatically associated to this work. So now you know exactly why you created the item, and you get end-to-end traceability for free. Once we get our pull request made, it's time for us to go ahead and collaborate over it. In a pull request, this is a way for you to review your code and have conversations with your teams to make sure that the code is quality. If you see that piece of code that gives you that warm and fuzzy feeling, you can actually share it with your team right here in your pull request. Our pull request can also run policies, and one of the policies that we run is a build. Our builds run a staggering 77,000 unit tests against every pull request, and we do this 600 times a day to ensure that we only ship the highest quality code to our customers. When our pull request is done, the code is now ready to be deployed into production. Here, we practice safe deployment. Safe deployment is where we deploy to one production environment, monitor the code before we deploy to the next production environment. This first environment, Ring 0, is where the VSTS team actually works. We dog food everything that we give to our customers, because if it's not good enough for us, it's definitely not good enough for you. We monitor our telemetry and application insights. We run queries against our bugs, and if we find any, we stop our release. This used to be a manual process, but now I can use release gates. Release gates allow me to have release management automatically run queries against my bugs, automatically watch my telemetry and application insights. And if it finds any issues, release management will automatically stop our release and protect our customers. We have automated safe deployment. Now, I know what you're dying to ask me right now. Donovan, how do we get started? Well, I'm glad that you asked. Because you get started in the Azure portal. We have a new feature called DevOps Projects that allow us to bring the power of Visual Studio Team Services right inside of the Azure portal. You get started like you would any other resource. You go to Create, and there is DevOps Projects. Gone are the days of you having to manually deploy code, or FTP. You don't even have to right-click inside of your IDE. And as Damian Brady likes to say, friends don't let friends right-click publish. And now they never have to. And if you look at this page here, you instantly see that this is not your daddy's Microsoft. This is a Microsoft that understands Go and Ruby, PHP and Python. Let's have some fun and let's do a Java application. I get to choose my favorite framework, which happens to be Spring. Now this is where the fun begins. I want to reassure you, if you're not ready for containers, don't let anyone pressure you into them. We can run your app the way that it is today inside of App Service. But if you are ready for containers, so are we. We're able to stand up an entire Kubernetes cluster for you and run your app inside of there. Let's have some fun with Kubernetes. At this point, you have to wire up your VSTS account. I see some of you getting anxious thinking, but Donovan, you don't have a VSTS account. We can create one for you right here on the portal. But if you happen to have your own, let's go ahead and choose one that I already have for myself. So we'll choose this one. I need to give the product a name. And now I click on Done. Now I just sit back and relax while Visual Studio and Team Services work together to build us an entire CI/CD pipeline for our Java application. When this is done, I'm going to have a portal just like this one. This is a blade that shows me everything from Visual Studio Team Services and Azure in one place. I can see my commits to my repository, the builds, and the releases. I can see my cluster and even infrastructure information coming from Application Insights down here at the bottom. If I click on this link, I get to see the sample application running in my cluster right now. Chances are you have your own code. So why don't we go ahead and show you how you can actually use your own code as well. Luckily, I can use the deep links here on our build pipeline. Jump right inside of Visual Studio Team Services, where I have complete control over this pipeline. I can simply come in here and say, why don't we edit our build definition? Let's get your code from where it exists today. Maybe your code lives inside of GitHub. So I come over here, and then I authorize my account. And then once I do, I have access to all my GitHub repos right here inside of Visual Studio Team Services. I'm going to choose my Smart Hotel 360, click on Select, and now I'm going to save and queue this build. I am now pulling code upon every commit from GitHub, building this Java application and packaging it as an image. I'm then going to take that image and deploy it all the way inside of Kubernetes. I hope you realize that this is not just a new era for Microsoft. This is a new era for all of us. Because when we combine the power of Visual Studio Team Services and Azure, here at Microsoft, we can implement DevOps for any language targeting any platform. Thank you so much, everyone.
So as Donovan just showed us in that demo, it's now easier than ever to set up the DevOps model using Azure. Using the new DevOps project support, you can set up CI/CD for the full application monitoring setup for .NET, for Java, for Node, for Python, and PHP with literally just a few clicks, or you can drive it in an automated way with the command line. And with today's updates, you can now easily do that both for web-based applications as well as container-based Kubernetes clusters using our new Azure Kubernetes service, or AKS as we call it for short. It supports Git-based source control repositories in both Visual Studio Team Services as well as GitHub, and you can get started with it now for free. So now that we've covered some of the developer tooling improvements that we're shipping this week, let's now jump into discussing some of the Azure platform improvements that we're delivering as well. One of the things that makes Azure really powerful is the coherent set of highly engineered services that enable you to build, deploy, and scale your applications even faster. For example, our Azure Web App service provides an incredibly optimized way to run web applications as well as expose web APIs. Our Azure Serverless Functions service makes it incredibly easy to host serverless apps and code that can scale from just handling, say, 1 request per second up to literally millions of requests per second simultaneously. And with both our Azure Kubernetes service and Service Fabric offering, we enable you to build modern container-based microservice applications. Let's talk a little bit about the new AKS service I mentioned. So our new AKS, or Azure Kubernetes service, provides a fully managed Kubernetes-based orchestration service. It provides built-in auto-patching, auto-scaling, and update support, which enables you to take the full breadth of the Kubernetes ecosystem when you're doing your development. And we're releasing a bunch of great updates with it this week at Build. One of the capabilities we're really excited to share is a new feature we call DevSpaces. DevSpaces enables a fast inner-loop development experience when building Kubernetes-based microservice applications. It enables you to edit and deploy code instantaneously, as well as debug and set breakpoints across multiple containers running in a microservice-based environment. And it's designed to work both great for individual developers, where it really shines is when you have a team of developers working together and you want to share a common team-based development environment and be able to test and iterate independently as appropriate. What I'd like to do is invite Scott Hanselman on stage to show off some of the new improvements we're shipping this week with Azure Kubernetes Service, as well as demonstrate how you'll be able to take advantage of DevSpaces to get a super smooth inner-loop development experience with Kubernetes on Azure. Here's Scott.
Hey, friends. So we saw Donovan take a Java app through Azure DevOps projects, and he deployed that to AKS. Fast forward 30 days later, and the project is a lot bigger, the company's a lot bigger, and let's say that I'm a new developer. So I need to get up to speed on how to work on this as quickly as possible. This is the site that I'm working on, and I'm gonna come down here because I was told that there was a bug. When people go and search for hotels, I can type in New York and I find my New York, but when they type in Seattle, it doesn't work. So something is wrong. However, this application has a lot going on. I'm going to switch over to Visual Studio. That's where I live as a Visual Studio developer. And this is where I feel most comfortable, and I see that there's 8 different projects here. There's 8 different projects here, and there's maybe dozens and dozens elsewhere. And I'm told by Brady, who set up the AKS environment, that each one of these projects within Visual Studio maps directly to a microservice that's running in a container inside of AKS. So if I switch over into Azure, I can see all the different containers, not just the ones that are in Visual Studio, but the ones that other teams are working on that might be running in different languages in different environments. You can see there's my hotel service. This is all running as part of Azure Kubernetes Service, which is pretty amazing because it is a fully managed service. I don't have any VMs to worry about. I didn't create a bunch of VMs and then install Kubernetes on them. I just have Kubernetes as a service. I can go and upgrade at any time. I can hit scale, and I can go and say I want 8 CPUs or I want hundreds of CPUs. It's totally up to me. Now within this cluster, I can also peer into the health of individual containers. You can see, so that's green, that's good. OK is good. I'm going to open that up. Here's all these containers, and I can scope my namespace. Mainline is where I'm told that the bug is, and all the services can be picked from. I'm going to pick hotels because that's the one that I am currently working on. If I click on hotels, then open that up, I see some interesting stuff that the CPU is about 4 or 5%. There's my hotels container that I want to debug because I think that's where the problem is. And I'm going to hit view logs. Now when I click into view logs, I didn't have to install anything. This all comes as part of the service. I got this rich logging experience right off the bat. And Brady gave me some queries to try out so I could learn this as a new developer. And I put a couple of those into the clipboard. So here, I can go and do a search and say run, and now I'm looking at aggregate CPU over all of the containers instantly. You see it was about 4 or 5%. So obviously my problem is not a CPU related problem, but I'm here to fix a bug, and I want to see if I can use the analytics to do that, because again, there's dozens of containers. So I've got a query here where I'm going to look for places that return 0 results, because when I typed in Seattle, I got back 0 results. And then I know that it's written in C#, because that's my language and that's the thing I'm working on. So I'm going to look for places where it contains the word controller. So hopefully we'll see if we can narrow down where this bug might have happened. And I can zoom in here and see the places where the bug has happened in the public web. And I can even change this and see how often that bug happens and then render it as a chart. Again, all of this built into the service and lets me do some amazing stuff. So I can see that clearly Brady checked into production at 5 and then just went home. So that's when the bugs started. So he won't be working here much longer, which is good for me as a new developer because I'm moving up in the company. So I know that it's in the cities controller because I saw that in my logs. I'm going to switch over into Visual Studio. Now within Visual Studio, I could go looking for it and hunting around in here, but I'm just going to hit Control-T because this is my steez, this is where I live. I know how to move around inside of Visual Studio. So I'm just going to hit Control-T and go to Cities Controller and see the microservice that pulls that data back. Here's my get default cities. I'm going to right click on, say, go to definition. These are the default cities that are hard-coded. And then up here, the actual microservice get that goes and talks to the back end. Now, we have 10 microservices here I can see in Visual Studio, but just so you can get a real sense, there's dozens elsewhere, and some of them are in different languages, but some of them are actual Azure services like Cosmos DB or Postgres or SQL. There's a lot going on to make this happen. So I go back over to Cities Controller and I say, all right, we're looking for default cities or, okay, and there's the bug. They didn't call get, they called get default cities, so that's a problem. They've actually only looking at the hard-coded cities. I'm going to change city queries to say get, pass in name, and go like this. Now I'm going to set a breakpoint, and you'll notice that this is all just the stuff that I ordinarily do as a Visual Studio developer, right? Nothing interesting going on here. However, if I were to hit F5 ordinarily, I might need to start up all of this stuff. Think about the amount of work it takes when someone says, hey, welcome to the company. Here's a laptop. Let's get this set up with a tiny production environment on your underpowered laptop, and then next week we'll make you more productive. That's a complicated experience. I don't want to have that experience. Instead, I'm going to use Azure Dev Spaces, and I'm going to run this stuff up in AKS. I have my own personal space up there. Now, I think it's my own personal space because there's at least 5 Scots that work at the company and a number of last names Scots. There could be 7 potential Scots that are going on here, but I think this is my space.
Anna, the Hive were carrying pieces of a machine.
Test, hey.
I hate when bugs decide
How y'all
to build
doing?
something. It's always unpleasant. There's more static coming from the tunnels. You can't have experimental Hive takeout.
It's all good.
Shut it down.
I'm not really sure how that's planning on working. So,
Let me add some value.
I'm Scott, I'm new here.
Okay, good.
So I've got my own space here within Azure Dev Spaces, and this is really significant. I want to point this out. Notice how hotels is boldface. That's the microservice that I want to debug. That's not the website. It's a microservice as part of the website that then talks to other microservices, like the profile of the backend database. When I hit F5 and go and debug this, it's going to do a lot for me. I want to point out that I don't have Kubernetes installed. I don't have any virtual machines here. This is not running here. It's running in Azure Dev Spaces. And this is my own private space. I'm just running that one hotels. Now, we've seen demos before when you hit F5 and then a miracle happens, but I really want you to feel this in your chest. We are not hitting F5 on the website. I just want to debug that one microservice. I'm going to compile all of this into containers, put it into Azure Container Registry, drop it into Kubernetes, and then when we hit the URL, we'll take a look at the URL, and you notice that it says Scott. That's my space, but I'm not affecting anyone else in my team because I want to make sure that I get an environment that feels like production but isn't. I type in Seattle, and now we're going to hit a breakpoint, and I can hover over it, and I get the great experience in Visual Studio as if I were local, but I have my own private space, dozens of microservices all working together, and I just pressed F5. So what did we see? We have fully managed Kubernetes. We've got auto patching, scaling. We've got upgrades. We've got an integrated container health. I searched terabytes of logs instantaneously. We've got the ability to rapidly debug and fix apps in a complicated environment like this with just Visual Studio and my Azure subscription. And thanks to AKS and Azure Dev Spaces, Azure has the best Kubernetes experience in the cloud. Thank you.
Scott and I have been joking for years that we got to do some kind of pair demo in a keynote. I guess we just finally did it, so that's awesome. So, as you look to modernize your application and adopt a microservice-based architecture, one of the things you're also going to want to take advantage of is serverless-based computing.
It's a signal amplifier.
Serverless-based
They're calling
approach
something.
allows you to execute code in an event-driven way, which can help guide you to build applications that can scale better. But serverless computing can also help you save money by enabling you to avoid having to pay for server resources that you might not be fully using. And Azure enables you to really build a serverless-based solution that can respond to literally millions of events per second. Our Azure Functions service enables you to execute on-demand serverless code written in a wide variety of different languages, including C#, JavaScript, Python, and Java. And our Azure Logic App service enables you to execute on-demand serverless workflows. These workflows can use more than 100 built-in data and app connectors that we provide out of the box, enabling you to integrate your workflows with data and actions that are in Office 365 or Dynamics 365, Salesforce, SAP, Adobe, Twitter, and more, and securely process and route data across long-running processes. These workflows can also then invoke Azure Function Apps, giving you a really robust way that you can integrate both code as well as declarative workflows together. Now, one of the new capabilities of Azure, you heard us talk a lot more about this week at Build, is our Azure Event Grid service. Event Grid provides a routing service that makes it easy to route events from a wide variety of different event sources and connect them to event handlers to process them. Event Grid guarantees reliable event delivery and will automatically queue, for example, messages for later delivery if your event listener is not available. And it can scale to support millions of events per second. And enables you to build really robust event-driven architectures that enable you to eliminate polling and the associated cost of latency within your applications. And it runs both in the cloud with Azure, but you can also, it's included as part of our Azure IoT Edge as well as Azure Stack offering. Now you can set up event grid routes programmatically using code.
I got a fragment of the
One of the cool
message.
things we're also doing starting this
Sabbath
week
emerge
is making
from
it
the
incredibly
deep.
easy
Take
to
our
set up
power.
events using the Azure portal as well. For example, this is a screenshot of a storage account in the Azure portal, so our standard Azure Blob storage service. And you'll notice now that we expose an events link on Azure resources directly inside the portal. If you don't have any events registered and you click that link, we actually provide sort of a nice helpful UI that enables you to easily create and run serverless functions or logic apps that'll execute when a particular event occurs. For example, here it's a sample tutorial that's built in now. We make it super easy to create and wire up a serverless logic app workflow that can execute, for example, every time a video file is uploaded into my Azure storage account. Here's what the logic app workflow looks like. You can see kind of compose this workflow graphically using our designer. And notice how the built-in workflow is taking the uploaded file and then in turn calling an Azure Cognitive Service that we call our Video Indexer service that'll automatically transcribe the speech in the video into a text file into that storage account. And the great thing is I didn't have to write any code. I didn't have to spin up any VMs or other services. Instead, it all executed serverlessly using my declarative logic app workflow. And this is just one of literally hundreds of new Event Grid and serverless scenarios that we're making super easy to accomplish this week. And all of our Azure services will expose events that can be managed using Event Grid with this type of serverless composition model. And where this container and event-driven serverless technology becomes incredibly powerful is when handling new types of massive scale solutions like IoT. IoT is now experiencing just exponential market growth. 2 years from now, there'll be more than 20 billion connected devices in the world. That's approximately 3 times the number of human beings on the planet. And the need for developers who can build IoT-based solutions is rapidly growing. We already have thousands of Azure IoT certified hardware devices in the market today, supported by hundreds of different partners. And what's great is that means as a developer, you can easily build Azure IoT-based solutions and take this hardware, take these solutions, and easily integrate them with our Azure IoT cloud services.
I'll get to the bottom.
And let's take a look at how we can do this. So our Azure IoT Hub service enables you to securely connect and manage up to billions of IoT devices. It was the thing that was on that back end when Sam was showing the drone, for example, in Satya's keynote this morning. And what's great about Azure IoT Hub is it can work with any IoT device out there and includes built-in security management capabilities. So for example, you can tell it to patch the device automatically, as well as device twin support, so that you can actually query and update the configuration of any device, even when the device is offline. And when it comes back online, it'll automatically update. And as a developer, it provides a great event-driven serverless programming model built on Azure Functions that enables you to both ingest telemetry from any device, as well as interact and program it from the cloud. Since I bet many of you here have never built an IoT app before, you're probably wondering, well, okay, that sounds good. How easy is it to do? What I'd like to do is invite Jeff Hollins on stage to show off, literally from scratch, how easy it is to build using Azure IoT Hub and our Azure Serverless Functions programming model. So here's Jeff.
Thank you all very much, and thank you, Scott. All right, so I want to show you just how easy it is for every single developer to get started building applications across IoT and the cloud. And to do that, Scott has given me a challenge to build an IoT application from scratch, live in front of all of you now, in less than 5 minutes. And the application that I want to build is going to center around this IoT button. Now, this is a very simple IoT device created by one of our partners. And how it works is that whenever somebody presses this button, it automatically wakes up, connects to Wi-Fi, and sends some data up into the cloud. Now, the application that I have to build centers around Twitter. So I'm showing here a Twitter account, hashtag Azure IoT Demo if you want to follow along. And what I need to build is an application so that if you're at the conference and you see this button, or buttons just like it, and you see something awesome, that you can press this button and let the world know through a tweet that something awesome is happening and where they can go to check it out. All right, so with that, let's start the clock and see what we can do. All right, the first part of this application is how these devices securely connect to the cloud. And for that, I'm in my Azure portal, and I can create a brand new IoT Hub. IoT Hub is an all-in-one service in Azure that allows me to connect, configure, manage, and monitor all of my IoT devices at massive scale. Now, I already have an IoT Hub in my subscription, so let's open it up here and see what it's doing. You'll notice that there's actually a number of devices already connected to this hub, and it's even been sending some data throughout the day today. And I can come in here and drill into the devices that I've paired with this IoT Hub. And I want to point out right here at the top of this list, this is my IoT button in my hand. Now, we need some code to run whenever these buttons are pressed. So to do that, I'm going to come here into Visual Studio and create a brand new Azure Functions project. This will enable me to have serverless code run on demand to all of these IoT events. And serverless and IoT pair great together because as I continue to add more devices and data, my application automatically scales. So in this new project, let's go ahead and add a new function. You'll notice there's actually a number of triggers that I can use to start this code, but I'm just going to use this IoT Hub trigger right here. And let's associate it with my IoT Hub in my subscription. Now, here's where I can write whatever code I want to run in response to events. And to prove this out, let's just change this line of code and have it say button pressed. And we'll click Save here and click Run. Now I'm going ahead now, and what's powerful with Azure Serverless is that I can actually run Azure functions locally on my machine and debug it. In fact, I've gone ahead now and just pressed this button, and you'll notice that my function on my PC was able to securely connect to IoT Hub, see that trigger, and run my code. In fact, just to prove it again, I'll press this button again, and you'll notice here we got another log message. So I can very easily debug and make sure my code is working before I deploy it. Now there's two pieces of information that I care about for my application to work. And the first is the location of the device. And that's because I want to include that location in the tweet of where something awesome is happening. And the second thing that I want to know is the type of message that's being sent. As you notice, my IoT Hub is actually filled with a bunch of devices sending lots of data. And before I go and send a tweet, I actually want to make sure that the type is in fact equal to a button pressed. All right, we've written about 6 lines of code here. This is where I know I need to post a tweet. But I've only got about 2 minutes left. There is no way that I can look up the Twitter API and figure out how the crap to grab an OAuth1 token in that amount of time. So instead, what I'm going to do is leverage another piece of Azure Serverless, which is Logic Apps. So I'm back here in the Azure portal, and here I can create serverless workflows. Now I'm going to add an action here, and what's powerful is that not only can I add other Azure functions that I've written, but there's over 200 connectors here out of the box to enable me to integrate with services like Cosmos DB, Cognitive Services, GitHub, Google Docs, the Microsoft Graph, even on-premises SAP. Now this is incredible for me as a developer because this is all function code that I don't have to write. So that if I want my application to do something like post a tweet to Twitter, I just select the Twitter connector, say I want to post a tweet. I've got some text here ready to go. Let's paste this in. And we'll even pass in the location of that device. All right, so that's all we need for the workflow. The last thing I need to do here is wire it up to my Azure function. So let's grab this URL here and write one last line of code. It's hard to write code when someone's looking over your shoulder. Imagine doing it in front of thousands of people. That's okay. Make sure to make this awaitable. I'm gonna add this, click save, run, time. All right, we've got time to spare. Let's test this out now. I'm back here at Twitter. I'm going to go ahead now and press this button. That Azure function has kicked off and triggered. It sent the location data to that Twitter connector. And when I click refresh here, you will see here now is a tweet sent to the world, letting them know that something awesome just happened here at Build. Thank you so much. Now what's great here is this even includes a sample on GitHub so that if you go check out this tweet, you can build the same solution in a few minutes later today. And I was able to build this entire application that could now scale to thousands of IoT applications in less than 5 minutes. Thank you so much.
One of the things that Jeff mentioned, if you go to our booth, we're actually giving out thousands of these internet-connected buttons. And so it's super easy to build this exact same app yourself and become an IoT developer. So, Jeff showed you how easy it is to connect, a simple Wi-Fi connected button to Azure, and how easy it was to basically write code in the cloud that interacted with it. And this is great for many, many different scenarios where you really only need to run the logic in the cloud. But as Satya talked about this morning, the trend that we're seeing is where we're also increasingly moving to one where you also want to be able to run logic on the edge as well, and interact both with the device and the environment in an even richer way, and be able to do it locally while still retaining cloud connection. Azure IoT Edge runs on both Windows and Linux devices and provides a really easy way to build and deliver application functionality on the edge. It supports a container-based programming model that you can use to both develop and deploy apps on the edge, and supports running serverless-based Azure functions directly on the device. In fact, we've taken the Azure Functions programming model, and it's just part of Azure IoT Edge, as well as Event Grid. And this enables you to use the same container and serverless skills and technologies that we just talked about running in the cloud to be able to run on the edge device as well. And you can basically deploy and run both code as well as your own AI models using our Azure Cognitive Services, or by building and training your own model, which we'll talk about in a few minutes, on the edge as well, and run it in the context of an Azure IoT Edge device. This gives you both an incredibly powerful and a very elegant way to build IoT solutions. What I'd like to do now is hand it back over to Jeff to show off how you can take this first IoT scenario that we just demoed and now extend it to build and deploy custom coded AI models using Azure IoT Edge.
Thanks, Scott. All right, so let's extend that application we just started. And what if instead of requiring somebody to press a button when they see something awesome, what if the device itself actually knew that there were awesome things around it and automatically sent a tweet? Now to do that, I want to talk about Azure IoT Edge. So I'm back here in my Azure portal, and this is my IoT hub. This is the same hub we were just using for my button. But I want to call out here that there's a section here for my IoT Edge devices. Now these are devices that actually run pieces of the Azure cloud directly on the device itself. And these aren't fancy devices that you have to special order. These are devices that you're likely already using today. In fact, two that I want to call out here is my Windows PC that I'm developing on right here, and this Raspberry Pi that's next to me, which is actually running Linux. Now both of these are edge devices, and both of them have cameras. So I want to leverage those cameras to be observing the environment and figuring out if there's awesome things around. So let's check out the solution and what it looks like. Now this inside of Visual Studio Code is my IoT Edge solution that I can completely build and manage here. A few things I want to call out. This same solution and same code is running both on my Windows PC and on this Raspberry Pi running Linux, and it's made up entirely of containers. Now this is great because it means as I'm building these, I get the benefits that containers bring, like portability and consistency, regardless of the form factor that it's running on. Now this solution is just 3 simple parts. The first one is this startup container. I'm just going to start it up on the device, grab the camera feed, and push that feed to a machine learning model. Now the second piece here, this is that machine learning model that needs to identify are there awesome things around or not. But what's exciting here is just how easy it was for me to build this. In fact, to build this model, I leveraged the Azure Custom Vision service. This is one of the cognitive services that enables developers to upload samples of images with tags. And after you train the model, you can actually upload new images that it has never seen before, and it will be able to predict for you what this image should be classified like. So let me show you the project that I built for this demo. You might be able to see here from the text. Here's my custom vision portal, and I want to build my own Scott or Not app, because chances are if Scott is somewhere at build, there's something awesome happening. So here's the sample images I've uploaded. It's a wall of awesomeness. Some of these images are tagged with Scott, and some of them are tagged not. And I can go ahead and tag these and then click this train button right up here. But I don't want to have to be sending the feed from all of my devices constantly up into the cloud to identify if it's Scott or not. And what's great here is that after training the model, I can actually click this export button and export this model to run on any device, even locally on the IoT Edge. So I've gone ahead now, I've trained this model. Let's choose that we do want to run this as a Docker container. Say I want this to be Linux, click download, save, done. This is the exact container that I have now imported into this solution, running now on these devices, looking at that camera feed and identifying is this Scott or not. Now that's generating a lot of data, and in order to deal with that data, I have my third piece, which is an Azure function, running on a container on the device. Now I actually want to show you that Azure function code because it should look familiar. This is the code here, and this is the exact same code that I wrote for my button a few minutes ago. The only difference is that this is running on the device locally, and you'll notice instead of looking if it's a button press or not, I'm actually detecting if it's Scott or not. Now I built this whole application, I've deployed it, and it works on my Windows PC. So now let's talk about this Raspberry Pi that I also want to run it on. So if you're not familiar, this is a Raspberry Pi right here. It's a computer the size of a credit card. It has an ARM processor, it only has 1 gig of memory. It can run Windows IoT Core, but for right now I'm actually running Linux on it. Now I want to pull in all of that power of the Azure cloud and run it on this simple device right here. So let's test it out now. I want you to pay attention to these lights up here because this is going to show us what the device is thinking. So here's the camera feed. I'm going to go ahead here and give a nice smile for the camera. And you'll notice that right away this device has rejected me with a red X, letting me know that I am not in fact awesome or Scott, getting flashbacks of high school. So we'll go ahead now, and Scott, if you'll join us, let's see if we can get something awesome to happen. If you'll go ahead and give a nice smile to the camera. And you'll notice that right away, this device has seen something awesome is happening. Thank you. It's actually posted another tweet with Scott's picture. Hopefully it was a flattering shot that it took of you, which also includes a link to this code. Now that's fantastic, and just an example how as a developer, I can use these powerful tools to build applications at massive scale on the Azure cloud. But when I need to, I can actually pull pieces of that cloud down, and run with that power on a device as simple as this Raspberry Pi. Thank you so much.
Right. Thanks, Jeff. So everything you've seen in all of these IoT demos is now available for you to use starting today. And you can build incredibly powerful IoT solutions using Azure and really take advantage of this intelligent cloud, intelligent edge world. Now, one of the most important decisions you'll make as you start to build large-scale cloud applications, whether it's for IoT or for any other scenario, is how to store and represent your data. So we'll spend some time talking about how you can do that with Azure and some of the cool new things coming out this week. Azure now provides an incredibly flexible choice of operational data services. Our Azure SQL database, Postgres, MySQL, Redis, and Cosmos DB services are databases that we provide as a service, which means we provide them as a database service with an SLA, and it's a fully automated managed service. Which means you don't have to manually configure your databases for high availability or have to manually patch or update. These are capabilities built into the services that we provide for you. We similarly provide built-in backup and both point-in-time restore capabilities. The ability to easily scale up and scale down capacity at will very quickly. And a whole bunch more capabilities. They're all just built-in features you can leverage. This enables you to be much more productive and build applications faster while still preserving the flexibility of your favorite database of choice. At last year's Build Conference, we released Azure Cosmos DB, which is the world's first globally distributed multi-model NoSQL database service that delivers horizontal scale-out with guaranteed single-digit millisecond latency. We've seen incredible adoption of the Cosmos DB over the last year, and it is today one of our fastest-growing services across all of Azure. And the reason for this incredible adoption is because it really enables you to build amazing cloud solutions. With Cosmos DB, you have a horizontally scalable database that puts data everywhere your users are. Cosmos DB enables you to automatically replicate data across all Azure regions around the world, giving your users lightning-fast performance regardless of wherever they're accessing your application. Cosmos DB allows you to scale your storage and performance throughput across one or multiple Azure regions with zero application downtime. You can start with just, say, gigabytes of data and then scale up to manage petabytes of it. You can start by processing just, say, 100 operations per second, but then scale to tens of millions of operations per second around the world. And best of all, with Cosmos DB, you pay only for the storage and performance throughput that you provision. And Cosmos DB is unique in that it allows you to program against it using a variety of different APIs and data models. We support MongoDB, Gremlin Graph, Table, SQL APIs, Spark APIs, as well as Cassandra APIs. And this gives you maximum programming model flexibility and enables you to easily reuse code and libraries that you already have. This week at Build, we're announcing a bunch of great new improvements to Cosmos DB. These include new pricing options that help developers achieve, in some cases, up to 10x cost savings over their solutions. And it also includes an incredibly powerful new capability, which is multi-master write support. Cosmos DB now supports unlimited read and write scalability by virtue of a highly decentralized masterless replication protocol support. This guarantees single-digit millisecond reads and now writes response time at the 99th percentile anywhere in the world, which is something no other database in the world delivers today. And with its unique adoptive entropy protocol, Cosmos DB significantly reduces write conflicts, which makes it much easier to build multi-master write scenarios and applications. In the event of a write-write conflict, Cosmos DB supports both a well-defined policy-based programming model that's built into the transaction system, as well as the ability for developers to add their own custom logic consoles. These are incredible innovations that really enable you to build truly planet-scale applications. And what I'd like to do now is invite Rima, one of the core architects of Cosmos DB, on stage to show off an example of how easy it is to use this multi-master write support to build amazing cloud solutions. Here's Rima.
Thank you, Scott. Good morning, everyone. It's really exciting to be at Build here this year. Now, imagine you want to build a planet-scale intelligent app serving millions of users all around the world. In this demo, I'll show you how easy it is to take any app and scale it globally using multi-master capability in Azure Cosmos DB. Now, to show you the benefits of multi-master for global scale apps, we have built a multi-user interactive canvas with millions of pixels inspired by the Reddit Place experiment. This app is running across all Azure regions with the data stored inside Cosmos DB and replicated across all Azure regions as well. The app needs to deliver instant writes and instant reads to millions of users worldwide. In this demo, I'll show you two canvases, one pointing to Replica in West US, and another one is pointing to Replica in Japan West. Users in those regions can draw and view each other's drawings in near real time all over the world. Now let's see this in action. So I will go to the canvas in West US and pick a color. And while I'm drawing, Ben is going to be drawing in Japan West. And I can say Cosmos DB, and as you can see, we can see each other's drawings in near real time. I can even draw maybe a tic-tac-toe game and play it with Ben.
I don't think we can get through.
So every single update from every single user gets written to the nearest region and becomes available all around the world in near real time. This canvas is stored inside Cosmos DB. So let's take a look at how this data gets stored inside Cosmos DB. I can come to the portal, click on the Data Explorer, and view this data, all of the pixels, the locations of the pixels, and the colors that get chosen by the users. Now, we're very excited for that. Right after this keynote, we're going to open up this application to all of the users worldwide, so all of you can participate in this globally distributed drawing experiment, powered by the multi-master capabilities in Azure Cosmos DB. Now remember, this is not just a regular app. This is a globally distributed application. Building such apps is really, really challenging. Azure Cosmos DB, as a natively built in the cloud service, was carefully engineered with multi-tenancy and global distribution from the ground up. With its turnkey global distribution capability, I can come to the world map, I can pick the regions where I want my data to be, click the Save button, and that's it. The data gets seamlessly replicated and becomes available for querying locally in those regions. And as I'm adding and removing those regions, my application does not need to be paused or redeployed. It continues to be highly available thanks to the multi-homing capability that Cosmos provides. Now, the key thing that I want you all to remember is that independent of the data scale, whether you're working with a petabyte or hundreds of petabytes of data, independent of the data model or the data distribution, or potential failures that may occur when you're running at such a massive scale, Cosmos DB continues to provide you with a single system image for all of these globally distributed resources. This is something that no other database in the world can offer you today. Now, the multi-master, and not just any multi-master, but the multi-master at true global scale. With its natively built-in multi-master capabilities in Cosmos, application developers get numerous benefits. Number one is you get unlimited and elastic write scalability all around the world. You can perform trillions of writes and reads every single second on a single globally distributed Cosmos database, whether it happens to be a graph or a table or a collection of documents. With the natively built-in multi-master support, you get 5 nines write availability all around the world, in addition to the 5 nines read availability, backed up by the industry-leading SLAs. With the natively built-in multi-master capability, you get a single-digit millisecond write latency guarantee at the 99th percentile all around the world. Now, databases that offer masterless replication can give you low latency writes, and they can give you high write availability, typically trading it off for consistency. What is truly unique about Cosmos DB multi-master replication is that it composes incredibly well with the multiple well-defined consistency models that the service offers you. So developers can make precise, intuitive, and well-defined trade-offs with respect to latency, consistency, high availability in Cosmos DB. With databases that support multi-master replication for active-active workloads, write-write conflicts are rampant. What that typically means, multiple users could be drawing to exactly the same pixel at the same time. This forces developers to add that logic to their application and participate in the multi-master replication protocol. In Cosmos DB, we wanted to remove all of that burden away from the developers. So Cosmos DB, in addition to its anti-entropy protocol that tries to reduce the number of bracket-level write-write conflicts down to the minimum. But in the case when a conflict occurs, developers can pick among multiple, flexible conflict resolution policies. Cosmos DB supports automatic policy with the native CRDT support. You can also write your logic in the form of a stored procedure as a custom conflict resolution policy or use last write wins. Now, in conclusion, with its highly decentralized multi-master protocol, multiple well-defined consistency model, and the capability where the developers can add and remove any number of regions in a scale-independent manner, Cosmos DB becomes a ubiquitous choice for the modern application development in the intelligent cloud, intelligent edge era. Every single app that you're building could transform the world that we're living in. And if your app happens to need a database, we sure hope it's going to be Cosmos DB. We're very excited to see what you're going to build with Cosmos DB. Thank you so much. Back to you, Scott.
Thanks very much. So let's now drill into how you can take all of your data and use it together with AI to add true intelligence into your applications. Our goal with Azure is to enable every developer to easily add AI to their application. With our Azure Cognitive Services, we enable you to easily call pre-built AI models that we expose through API services. As you heard from Satya this morning, we provide great AI models to do things like speech-to-text translation, image detection, object detection, video translation, language services, and more. And you can invoke all of these using either our REST APIs or by using our pre-built .NET, Java, Python, and Node SDKs. Now, in addition to calling these cognitive services programmatically, one of the cool new capabilities that we're making available today is native integration of cognitive services with our Azure Search service. Azure Search enables you to index any type of content and build rich search experiences from it. And with this new cognitive services support, you can now, for example, just automatically index images, videos, and PDFs. Use AI to extract all that insight from it. Things like face and object detection, sentiment analysis, and video transcription, and just expose it directly as part of your search experience. Now, we've worked with some great customers using our Azure Cognitive Services. One of those is the NBA, who are using it to deliver some really great experiences. And please join me in welcoming Garth Cakes from the NBA to talk a little bit about the work they're doing with us and what this experience enables. Here's Garth.
Thanks a lot, Scott. Good to see you. All right. So I'm going to start out with a question. Show of hands. How many NBA fans do we have in the room? Okay, it's a reasonable amount. So my name is Garth Case. I'm in my 20th year at the NBA. There are two questions I get asked most frequently. The very first one is, have I met Michael Jordan, Shaq, Kobe, or LeBron? I'm lucky enough to say yes to all of that. I have. The second question, though, why have I stayed so long at the NBA? The answer might seem cliche, but it truly is because of the people. Working for the NBA, I've had the opportunity to meet and learn from the best and brightest in sports. Now, for those of you that don't know, during the NBA regular season, 30 teams play 82 games. Each game generates terabytes of content. As you can imagine, this much information makes it difficult to manage and curate and get insights delivered consistently across all our internal and external channels. Now let's talk about the NBA's journey to finding a solution to our growing data problem. 18 months ago, when we first started to organize and understand our data, we started like most, thinking that we could build a data lake and that would solve all our problems. But our data lake quickly became a data swamp. And it was difficult to hear important signals in the data through all the noise. Even though we had designed the perfect analytics layer, we needed something more. We needed a learning layer. Analytics layers are usually active post-ingest of data, but a learning layer could be active through all stages, from ingest all the way to archive. It would help us organize and graph our data, surface patterns that connect dots and allow us to focus on the high-value information. You would now be able to hear the signals loud and clear. This pivot in our journey meant that we were no longer building just a data lake. We're building a smart data platform. This revelation gave birth to many use cases and scenarios. Most of them related to data mining, process automation, and decision intelligence.
Stay where you are.
As I searched for technologies that we could use to build our smart data platform, I saw a demo where Microsoft used an AI-driven approach to understand the recently released JFK files. They were able to run thousands of unstructured documents through their system and build a knowledge graph using a set of AI models and services. Their use of new cognitive capabilities in Azure Search, as well as leveraging custom and pre-built AI, appeared to be the perfect recipe for a cocktail that would enable us to understand our content and add the layer of learning and intelligence we needed to build our smart data platform. Now, as we built the platform, we also developed plenty of value-driven use cases and scenarios. One of these use cases in production today is the application called NBA Photo Sorter. The name is not terribly creative, I know that. But please feel free to tweet me if you have any suggestions. Before the photo sorter was created, the effort of tagging photos took a very, very long time. Extremely manual, resource intensive, and sometimes inaccurate. Now with the help of Azure, photos and other types of content can be automatically tagged and related quickly and increased accuracy. The photo sorter has already aided us in quickly tagging VIP photos from our events. These photos are turned into printed and digital albums, which are given to VIPs as a personalized gift. But this example is just the beginning. As we get more insight from our data, I see a future where we can not only further automate our business, but use the system to connect our channels and drive personalized, value-based engagement with our fans across the world. Together with Microsoft, we've embarked on a journey to bring AI into the world of the NBA across all types of data and content. My intent is to use AI to power the next generation experiences for our employees, our teams, fans, everyone around the world. I have one plug before I turn it over so you can check out the photo sorter. At this very moment, we are in the semifinals of the NBA playoffs, where you can experience the excitement of watching the best athletes in the world compete for the title of NBA champion. I hope that you all will tune in and share the excitement with me. Now I'll turn it over to, I think, don't have her name, Paige, is that your name?
Yep.
To do our demo. Thank you.
Awesome.
All right.
Thanks so much, Garth. So as we just learned from Garth, the NBA truly is a data-driven organization. And here we've ingested all of the NBA's content, so videos, images, text documents, player telemetry, into blob storage on Azure. And we've applied cognitive skills to enhance and annotate that data. So I'm from Houston, which means that the only James I care about is James Harden. But I understand a lot of folks on this coast like LeBron. So let's see what our cognitive skills can tell us about LeBron. Here, our Face API has automatically detected LeBron in this image, and it's been trained on all of the players, owners, and coaches in the NBA. So not only do we have his face, we also have lots of other additional metadata, such as emotion and age. So how does the king feel as he's about to score an epic shot in front of tens of thousands of people?
We got
Neutral.
incoming.
Stay where you are.
Completely in the zone.
Lock on with the Warsat.
And this guy looks like he's about to be sad in about 5 seconds. But it's not just about LeBron. How does he relate to other entities in and around the NBA? Let's take a look at the knowledge graph that Cognitive Search has automatically created for us. So this is interesting. It looks like our AI skills have detected that there's some sort of relationship between LeBron and Nike. So let's explore that a little bit further. Here, our object detection API, which has been trained on all sorts of items that you would expect to see in the NBA. So basketballs, hoops, players, shoes, and even specific brands of shoes, have determined that LeBron apparently loves wearing Nikes. And so now we know a little bit more about his fashion sense. Let's try and take a look at his performance. So how is he as a defensive player? We get back a short video that our Video Indexer API has automatically annotated and transcribed, showing LeBron make a defensive play. So he's good at offense, he's good at defense. How is he as a player all up? That's usually done with something called game notes. These are PDF documents created after every single NBA game, and they contain a wealth of information. So player stats, scores, play-by-plays, and we could look through every single one of these PDFs to try to build this player top performers column here on the right. But since we've already extracted all of the text from the tables and the documents themselves, we're able to build a custom algorithm with Azure Machine Learning to extend cognitive search. So this all sounds kind of like magic, right? Like being able to apply cognitive skills to the data that you've already got in Azure. So how easy would it be to go about creating this solution for yourself? Let's dive into the portal and see. So if I wanted to create a search service, all I would need to do is go to Create Resource, Web, and then click Azure Search. Or you could just search for search, I guess. But since I've already created one, let's take a look at the NBA Content Search service that's powering our application. If I wanted to import data, I would connect to my data source, and I can use a variety of things. So SQL databases, SQL data warehouses, Cosmos, Azure Blob Storage. And if we take a look at our existing data source, this NBA Docs content, we get pulled up the container with all of the items that we've seen before. So our videos are automatically being annotated. I'm being transcribed. Our PDF documents are having the text extracted and the images automatically documented and described. And we can even apply cognitive skills out of the box to extract people names, locations, and languages. And as mentioned before, we can also extend this cognitive search with custom machine learning logic. Once this has all been created, we can go and look in the Search Explorer and search against all of the returned JSON. So I type in LeBron, we get back every single instance. I can even do more complex queries. So search equals LeBron, and facet equals organizations, one of those things that we just clicked before, those little checkboxes. And here we get back all of the organizations that LeBron is associated with. So the Cavs, the NBA, and Nike. So these cognitive capabilities, being able to apply AI to the data that you already have stored on Azure, this capability is only available with us on Microsoft's Azure platform. And they're available for public preview starting today. So I can't wait to see what you create with this AI-first approach to cognitive understanding. Thanks so much, guys.
So the great thing about Azure Cognitive Services is that you don't have to be an AI expert in order to take advantage of AI within your applications. But we also know that a lot of you want to be able to build your own AI models and tailor them to your precise business needs. And we provide a great way to do that on Azure. So when you typically want to build an AI model, you typically walk through a workflow where you do three things. Step one is where you prepare your data. Step two is where you build and train an AI model from it. And step three is when you deploy the model and start using it within an application. Let's walk through how we're trying to streamline all of these things using Azure. So I'm going to start with sort of a simple example to illustrate these three steps. And that is trying to build an AI model that can help answer the question of how much a particular car is worth. So step one of this process, again, is to prepare my data. Now, data scientists building AI algorithms spend on average about 80% of their time doing data preparation steps, working from multiple data sources and merging the data together, finding and fixing anomalies and outliers, and standardizing on formats. It's a really arduous task, and a lot of people often refer to it as data wrangling. Our Azure Databricks service is an Apache Spark-based analytics service that's optimized for Azure. It enables you to quickly launch and scale up Spark clusters on demand. It includes a rich interactive workspace that makes it easy to build Spark-based data workflows, and also includes built-in data adapters that allow you to work with all the different data that you store within Azure. And it makes it really easy to prepare data for AI-based workflows, whether you're just working with a few gigabytes of data all the way up to hundreds of petabytes of data. Now, once we've got our data assembled for our car model, the next step is to build and train an AI model using it. Now, for example, for our car scenario, you might want to create and train a model that predicts the value of the car using a data set of historical car prices. And this process of building, training, and testing the model is going to be iterative as I evaluate various different attributes and hyperparameters to more accurately fit the model as part of my solution. And our Azure Machine Learning Service helps dramatically with this process. It enables you to train and evaluate models on any number of servers within Azure. You can literally scale up from using just one server to build and train your model to literally running across hundreds of thousands of servers with just a single parameter change in your application. Azure Machine Learning enables you to use every popular data science and AI framework out there, including TensorFlow, Caffe2, CDK, Keras, PyTorch, and more. In addition to every popular AI framework, we've also included pre-built AI models with Azure, specifically designed for computer vision, text, and forecasting scenarios. These can dramatically improve both the performance of your AI models, as well as the speed with which you can go ahead and build solutions with them. And once you have built an AI model with our Azure Machine Learning, you can then package it up into a Docker container and deploy it to run anywhere. With our Azure Machine Learning Service, you can build and deploy AI models that literally run anywhere. This includes our new Azure Kubernetes service installed in Matt Hanselman demo earlier, which is great for hosting an AI model that you use for online API scenarios, or our Azure Batch service if you want to iteratively batch-based process lots of data. Or you can deploy it, as you saw Jeff show, on IoT Edge for edge-based computing scenarios. And because these models are container-based, you can also run them anywhere else as well, including on-premises environments. This gives you maximum flexibility to use AI literally everywhere. And the great thing is you can take these sort of three-step flows and use it with any data stored inside Azure and make any application you work on much more intelligent. And what I'd like to do is invite Starbucks, who is another great customer of Azure, on stage to talk about how they're leveraging both our Azure data services and AI services to transform their customer experiences. So please join me in welcoming Jeff Wiley on stage here to talk about Starbucks and the great work they're doing. Here's Jeff.
Good morning. Can I borrow that?
Sure.
Well, good morning, everyone. It's a pleasure for me to be here. Hope you're having a great morning so far. This is great. And it is my pleasure to have the opportunity to spend a little bit of time sharing about how an iconic brand like Starbucks is being transformed by many of the same technologies that we've heard about this morning. Many of you know us, but let me share just a little bit more about what Starbucks looks like today. We have 28,000 stores around the globe, over 300,000 partners who proudly wear the green apron in 77 countries around the globe. All of this equates to over 100 million occasions each week where our customers visit a Starbucks store. And that equates to about $22.5 billion of revenue last year. We like to say at Starbucks that we earn that $22 billion $5 at a time. So how does all that happen? Well, our company has been built over the last 40 years on 3 really important pillars. Number 1, hire great partners who care passionately about the craft of coffee and who care about the customers that walk into our stores. Number 2, build innovative and exciting handcrafted beverages and unique food offerings, such as our brand new Nitro Cold Brew. If you haven't experienced it yet, it's life-changing. I promise you will love it. And finally, stores that are welcoming and a great place to refresh and relax, which many of you have come to call the third place. But we've added a 4th pillar recently, and that is technology, because we believe that technology is the enabler at Starbucks to spread that experience everywhere. Let's take a little bit of a closer look on what that technology is doing to transform our systems. We're looking to use technologies like blockchain to track our coffee around the world from bean to cup. We're using data and modeling to share best practices with our coffee farmers around the world. We're developing systems to optimize inventory so we are delivering the right products to every store at the right time, while at the same time delivering or reducing waste. And finally, we're creating new capabilities that optimize scheduling for partners, those 300,000 partners in the stores, to make sure that they're there when they're needed. And let's not forget our industry-leading mobile application, where we're leveraging scalable infrastructure that adjusts automatically as demand changes throughout the day. But probably the biggest transformation for Starbucks as a whole is in our partners, who have been able to innovate faster and build solutions more quickly for our business than ever before. So what do all these have in common? Well, every one of these projects leverages cloud platforms like Microsoft Azure, which enables us to move faster and build better solutions. We're also partnering closely with great companies like Microsoft, who not only help us along this journey, but are teaching us as they go. Finally, another benefit we see from the cloud is our ability to deploy these solutions globally. We can build it once and leverage it anywhere around the world that Azure may be. It really is helping transform our business. So let me give you a specific example that we're super excited about. Over here you can see a typical store, and we have orders coming into that store, maybe a mobile order, maybe a drive-through, or maybe someone walking up to our register. Today our partners do an amazing job to fulfill and craft those orders, but we do it in the order that the sequence that the order came into the store. Things get made, things get picked up, and you can see we do our very best to satisfy our customers. But what if we could use big data and machine learning and AI on something as simple as creating coffee in our stores? And we could use those algorithms to help us optimize how we produce those orders. We still have the same number of orders coming in, but maybe that drive-through order is just a cup of coffee. So we're going to fulfill that first, instead of first in, first out like it is today. And once that's complete, we've now handcrafted that large order for our mobile customer, and it's there, ready, right when they need it. We're super excited about this capability because it enables our partners in the stores to focus on our customers and not spend time trying to figure out how to manage that queue. And we're leveraging things like Azure Cloud and the capabilities like Service Fabric.
Let's begin.
IoT Hub for our connected devices in the stores, and back-end data stores like Cosmos DB to enable all of this and make it happen. Who knew there was so much technology behind a simple cup of coffee? Our mission at Starbucks is to inspire and nurture the human spirit, one person, one cup, and one neighborhood at a time. And together with partners like Microsoft and technologies like Azure Cloud, we strive every day to fulfill that mission. Thanks for listening, and enjoy the rest of the conference.
Thanks, Jeff. So you heard about how Jeff is, and Starbucks is using Azure to better improve their customer experience. Let's now walk through an example of the steps involved to build an AI model for a scenario like this. And to do that, I'd like to invite Paige back on stage to show us how. Here's Paige.
Hi again. Awesome. So if you've ever worked in a restaurant, you know it's an art and a science to prepare a complex order at precisely the right moment for a customer to arrive. And what we have here is a restaurant owner's dream. Orders come in on the right, I click on them to confirm them, and they're automatically placed in the correct order on our order queue. So I'll complete Harvey's order, then Francis's, then Barbara's, and I am sure that all of them will be ready at precisely the right time as my customer arrives.
Come see me again, Guardian.
So how would we go about creating this solution backed by a deep neural network? Let's dive into Azure and see. So here I am in my Azure portal using something called a Databricks notebook. And this is an interactive, collaborative programming space for data scientists and software engineers to work together. Using Databricks, you can pull in data from a variety of sources. So here we're grabbing stuff from SQL Data Warehouse, Cosmos DB, and also some static CSV files that we have hosted on Blob Storage. Once our data's been pulled in, we can prepare it, remove outliers, remove null values, get it into a nice rectangular data format, and then use that to build and train our model using any framework, as Scott mentioned. So if you like TensorFlow, use TensorFlow. If you like MXNet or Cognitive Toolkit, you can use those too. And then once your model's been trained, and once our hyperparameters have been tuned, you can package it up into a container and then deploy it anywhere you choose. So locally on an IoT edge device, or even at scale on a Spark cluster in the cloud. And any developer in your organization can then call that model just as easily as they would a cognitive service. So let's take a look at what that would entail. So first, we bring in our data. And if I click Shift-Enter, automatically, we're sending a request to the Spark cluster to pull in data from our SQL Data Warehouse. I even have data streaming in live from Cosmos DB. So let's take a look at that here. Awesome. I can also pull in orders just from Blob Storage. So here we're grabbing a CSV file. Now that all the data's been ingested, it's time to prepare it. So we probably don't want to keep these outliers. That would probably skew the model that we're building. So if I want to remove them, I would do orders.total order amount.
Thanks for shopping Eververse.
Less than, say, 200. That seems reasonable. I click Shift-Enter again, and automatically my graph changes. So that looks like a much more representative sample. Now that we've got our data in a great state, it's time to join it and prepare our model. Here we have a neural network with 2 hidden layers, and we have 200 nodes per layer. As I mentioned before, this is backed with TensorFlow, and we're using Keras as the developer-facing